everyone can fill up the attendance form. Alright. Okay, we are now in chapter 4, still in chapter 4, the last part. Okay. Before that, let me recap first. So we have cover 4.1 and 4.2, and today's class we cover the two last subchapter, the piping network, and also the application of the steady flow energy equation, the extension of the Bernoulli equation. Okay, so we will look these two subchapter today. Okay. Before I go to the new subchapter, the piping network, I would like to stress again about this Moody chart, because I have a question. Someone asked me about this Moody chart. Because in this example, when I show you this example, is quite straightforward, because you have relative number, Reynolds number 30,000 here, and you have your relative roughness is 0.08 here. Okay, and you draw this intersection, and you go to the left, and you find your Darcy friction factor here, kan, 0.035. But what happens if your relative roughness is not this lies in this line? Because this number, if you look from this Moody chart, there are this purple line, kan, purple line ni. Okay, so you can, if you get that number, it's easy lah. But if you get number in between, which is not the, sorry,
dia tinggal present ke sir?
tak dapat.
Tak.
Saya tak share lagi. sorry. Baik awak tanya. Sorry Dia lupa pula nak share screen. Okay. Now you can see my slide. Boleh nampak slide
Boleh,
saya? Boleh. Okay. Sebab saya tak pergi panjang. Okay, before that, show again. So today we will cover the last two subchapter, which is the piping networks and also the energy equation, the extension of the Bernoulli equation. So these two we will cover today lah. Okay. So before I go to the new subchapters, okay, I got a question from you guys. Someone asked me about what happened if, in this Moody chart. Before this, in the last class, I show you the example. It's very easy lah, because you got Reynolds number 300,000 here, and your relative roughness is 0.008 sini, and this purple line. Okay, you just follow the line, and this intersection you follow through until you get your F and your friction factor. But what happens, okay, if your relative roughness, okay, is not the value with this line, tak ada line, kan ada line kan, awak nampak kat Moody chart ni. Okay, if you want in the exam, you will be provided lah with this Moody chart. But if you want to do exercises or tutorial, you need to have your Moody chart lah. So you have this purple line ni kan. Okay, if your value is in this purple line, that's fine. You just follow the line and see where is the intersection kan. But if your value is not in this line, somewhere here kan, okay, somewhere here, okay, let's say 0.005, okay, so you need to estimate the middle point of this point. So this is 0.005, and you need to draw your line, your purple line, your own purple line, okay, straight line, okay, until you reach this dotted line. You can see one dotted line ni kan, nampak dotted line ni? Can you see that?
Yes sir.
Okay, what is this dotted line? Okay, let's say your Reynolds number is ini apa 10 to power of 5 10,000 10,000 lah. Okay, let's say your point, your Reynolds number is 10,000. Okay, so this is your point. So when you draw your line upward, okay, so kat sini kan, okay, when apa, to get the intersection point with the Reynolds number and with your relative roughness, after you draw the line from your relative roughness, straight line, when you reach this dotted line, you need to make apa, the line tu melengkung juga, follow the trend. Saya semua nampak kan, dia melengkung ni kan. Can you see that? After this dotted line, every line started to melengkung kan, macam tu kan.
Yes sir.
You need to do the same. If your line is 0.005, you draw a line until you reach your apa, this dotted line, then draw the curve line, macam tu juga. Faham? Then that point is intersection, then you follow your line until you find your friction factor. Boleh faham?
Faham sir.
Okay, so you cannot just simply draw a straight line. Okay, you need to draw your line curve after you reach your this dotted line. Okay, say after that's mean apa, because this is the turbulence region, that's why this model chart draw something like that lah. Okay, so you need to draw a curve line. Maybe there's a few error lah because maybe your apa line tak berapa curve ke apa, that's fine. Just apa, that error will very minimum lah, very minimal. So that's why we still using a model chart. Okay, so you draw a curve line, then that intersection, then you draw to the left to get your friction factor. But if you got the value which has this purple line, 0.02 ke 0.04, 0.06, just follow the line and then where it intersect with your Reynolds number. So that is your point to the left, and you will got your friction factor. Okay. So thanks to the one who asked me. Okay, I totally forgot about that. For this example ni senang sangat lah just one point and then the point, and where apa intersection you just follow to the left. Okay, because this point is still within apa before the end apa this dotted line. That's why it just apa draw a straight line until this intersection and follow through until the left axis. Okay, but if the Reynolds number is after this dotted line, so you need to draw this curve line lah. Okay, alright, so that's the want to emphasize again on the model chart. Okay, let's go to the new subchapter, which is the piping networks and pump selection. Okay, in any plant or any refinery plant or power plant ke, you will see this piping network lah. Okay, if we have a site visit, hopefully we can do a site visit in the future. So you will see this piping network in the plant or in industry lah. Okay, there are a lot of connection. Okay, a lot of line, and normally there are two types of piping networks. Okay, one what we call as series, as this picture, and your pipe is just connected in series. So pipe A and pipe B connected in series kan. So this is the first piping networks, and the second one is what we call as parallel. What is different is the pipe is ada dua junction or tiga or four, tak kisah berapa, but at the end of the junction, okay, it will combine again. Okay, as this picture, ada one junction and second junction, and after that it combine again at the end. So this is okay. So these are the two piping networks lah. in a industry facility or in any power plant or oil refinery. Okay, so what is the differences between these two piping network is, okay, for the first one, for the series, because it is connected in series, okay, the flow rate is the same in each pipe. The flow rate ni V dot ni Q lah, Q. I use Q kan before kan. Okay, let's so you will not confused. Okay, the volume flow rate, okay, in each pipe will be the same. Okay, QA and QB. Okay, alright, because it's connected in series. And the total head loss, HL, okay, will be the sum of each individual pipe. In pipe A, you calculate in pipe A, and you calculate for pipe B. So summation of these two head loss will be the total head loss for this pipe. Okay, so this is what is mentioned here. Okay, the head loss between point 1 and point 2 is the summation of the head loss in pipe A, HLA, plus the head loss in pipe B. Okay, because it connected in series. Okay, so these are the two things that you need to remember for pipe in series. But in parallel, in a piping parallel, the head loss, okay, the head loss of this pipe will be the same for each individual. So the head loss in pipe 1, kat sini, okay, the head loss in pipe 1 will be the same the head loss in pipe 2. Okay, it's not the summation lah. Okay, that's why it says here the head loss in pipe 1, and ni awak kira ni will be the same the head loss in pipe 2, regardless their diameter or their length or whatever. So this head loss must be the same. The total head loss for each pipe, individual pipe, is the same. Okay, but the flow rate of this piping network parallel, you need to add the flow rate in the first pipe and the second pipe. Summation of that will be your total volume flow rate yang kat B ni lah. That's why it says here the VA equal to V1 plus V2, or Q lah, Q1. So QA equal to Q1 plus Q2 and equal to QB lah. Okay, QB pun sama lah, summation of Q1 and Q2. Okay, so that is the difference between piping network in series and in parallel. Okay, we have discussed this before, kan? Whenever you have continuity equation, if you have a branch, if you have two branch, so this or three branch, so the Q1, Q2, Q3, this summation of this volume flow rate will be equal to this the main flow rate lah, the one that is enter when dia pecah-pecah. Okay, you need to add the summation of each branch, kan? So similarly in a piping network, if you have these two junction, okay, this total flow rate will be the sum of individual pipe. Okay, if you have two pipes, you have to add these two pipes. If you have three, then you have to add another one. Okay, so that is the difference between piping in series and also in parallel. Okay, any question about that?
No, sir.
So that's you need to understand the head loss and the volume flow rate depending on your pipe networks lah, whether it's connected in series or it connected in parallel. Okay, so this analysis of piping network is based on two simple principles. First of this, conservation of mass, the continuity equation lah. Okay, must be satisfied if you have a piping junction, so you need to add all of that. Okay, if you have a series, so it will be equal. Okay, that's the first principle lah. Okay, continuity equation kan, conservation of mass. The second one is the pressure drop, or in terms of head loss, okay, we call it head loss, between the two junctions must be the same for all path between the two junction. Okay, kat sini pressure drop ni masih sama lah. Okay, whether it's pipe 1 and pipe 2 must be the same. Okay, so that's two principles that the piping network based on conservation of mass, and also the pressure drop, the head loss between the two junction must be the same. Okay, so these two principles that makes up this ni lah the difference lah between these two, whether the flow rate is the same or the head loss is the same. Okay, it will be depending on your piping network. Alright, so that are the third subchapter about the piping network. Okay, the last subchapter which about the energy equation. Okay, as I mentioned before, in chapter 3 when we learn about the Bernoulli equation, we using the Bernoulli equation something like this kan, P1 over rho G plus Z1 plus V1 squared over 2G equal to P2 over rho G plus Z2 plus V2 squared over 2G kan. So this is the Bernoulli equation in chapter 3, where we assume the flow is no losses. Okay, there are no friction. Okay, that's why we don't add any mechanical device. It just flow by the pressure difference. Okay, and there's no heat in or out. Apa lagi assumption kita itulah so that's why we can use this Bernoulli equation. But in reality, as we discussed before, there will always a friction and there will always a losses. Okay, so because of that losses, we will put commonly people or industry will have a pump, okay, inside the piping network. Okay, and so we add a mechanical device to help us to help the flow to flow until the end point lah. Okay, so we cannot use this Bernoulli equation anymore. Okay, so that's why we have the extension of that Bernoulli equation. Okay, because we have a pump. Okay, because we have the losses. Okay, we have the losses, so we take into consideration of the losses. So because of that losses, we put our pump. Okay, we add the pump to aid and the flow, and sometimes maybe you also add the turbine lah to berpusing kan. So in the piping network, you sometimes the operator want to have turbine as well, so the flow will rotate the turbine. Okay, that fluid flow is the source of energy for that turbine to rotate or to do whatever lah, and the turbine will do some other works kan. Okay, so there are we add also in the equation. Okay, so the question is, because we this sign whether it's minus or plus so because we take into consideration of the heat of the losses, okay, the head loss, so that's why we minus the head loss. Okay, in this right equation kan, we minus the head loss. Okay, because we know we have the losses. Okay, because of that losses, so we add a turbine, a pump kan. Okay, the pump. So because the pump ni benda yang cover back the losses. Okay, because you have the losses and you want to cover back that losses, so that's why the sign is plus. Okay, kat sini plus so this pump will give the mechanical energy to flow, to help the fluid to flow. So that's why we have the plus sign for the pump. Okay, that's why the plus the head for pump. Okay, and lastly, because sometimes if the operator want to use a turbine to rotate, to do another work, okay, and this turbine will reduce the energy lah. Okay, so that's why we minus, the sign is minus for turbine. Okay, so that's why you will end up with this equation. Okay, P1 over rho G plus Z1 plus V1 squared over 2G minus the head losses, because you have that friction, major and minor, and you will have that losses, and because of that losses you will need a pump to cover back. So that's why you add the head for pump. Semua ni head kan, head in meter kan, so head for pump in meter, and head for loss in meter as well. That's why you add head for pump. And if you have a turbine that make another work, okay, so you will minus that head for turbine. Okay, and this will equal to the P2 over rho G plus V2 squared over 2G plus Z2 lah. Okay, saya orang masuk jap. Alright, can someone just copy and paste the link, the attendance link? Thank you. Okay, so this is the full equation when we take into consideration of the head losses, of the head pump and the head turbine lah. Okay, if you have the turbine. Okay, so this is the question. You need to use this. Right? Any question or anything before we do some of the example? Ada soalan?
Tak ada, sir.
Tak ada? Okay, never mind. Okay, this picture, this diagram shows you the flow from reservoir to another reservoir, which is higher than this reservoir. So that's why you have a pump to make the fluid to flow and put it against the gravity kan. Okay, and also you have the losses. Okay, that's why you will add a pump. Okay, and in this picture you don't have any turbine, so you can just cancel out lah this turbine kan. Okay, and so you can calculate the head losses, okay, from the information lah, whether you find the major losses and then the minor losses. Okay, you will get your head HL, and then you can find out what is the pumping power requirement lah if they ask you from this question. Okay, if there is no pump, that means you can just ignore the H pump lah. Okay, that means the flow is just depending on the pressure difference, the gravity difference ke. Let's say the fluid come from this top reservoir to the lower reservoir kan, so the fluid flow from here to here kan. So that means it's much easier, and you will not, even though there are few friction, okay, maybe it will say the friction is negligible, and so in that case you will not need any pump lah. Okay, so this pump will not be used anymore, so you can just ignore the H pump lah. Okay, so that's how we apply this energy equation. Alright, so any pump, okay, or any motor, okay, there will be efficiency kan. Okay, they are not working at 100% efficiency. They always have a few friction or losses, so that's why normally it has efficiency lah, 0.7 or 0.9. So you in a question, if they give you that information working at efficiency of 70% or 80%, 50%, depending lah on that question, we need to take into consideration of that efficiency. And before this, when we discussed about the pumping power requirement, dekat sini, dekat pumping power, so we just multiply the volume flow rate with the pressure losses, okay, or the volume flow rate with the rho GHL lah, because we know pressure losses equal to rho GHL, okay. In this case, we assume the pump working with 100%, okay, 100% efficiency. There's no losses or no whatever lah. But in reality, sometimes if they provide you with that efficiency, okay, we need to divide that equation with the efficiency lah, okay, this efficiency. So this will give you the total pumping requirement, how many watts that the pump will give, okay, if the pump has 70% efficiency or 80% efficiency, okay, you need to divide that efficiency lah, okay. If they assume 100%, so there's no need to divide that, or just divide by 1 lah. So divide by 1, so it means there's no any losses lah, there's no losses. Okay, so they will give you the pumping the efficiency, whether it's 0.7 or 0.9. And if you have the pump and motor working together, and each component has their own efficiency, in this example, so they have a pump efficiency and also the motor efficiency, so you need to multiply that both efficiency to get the total efficiency of this component, 0.63. Okay, if they use only pump and there's no motor, so just use the efficiency for pump lah. Okay, so that's how you need to divide that efficiency when you want to calculate the pumping power requirement. Alright, okay, and this need nothing new lah. We have discussed this, why the flange, elbow and sharp turn. Okay, the minor losses coefficient is different. Alright, any question about this efficiency? Anything? Any question?
No, sir.
Okay.
Oh, no, sir.
Alright, if there is no question, so means you understand. You understand the chapter 4. So we can do few questions lah, okay, today, and you can do by your own. I posted in the Google Classroom the tutorial. There are few tutorial that you can do, and you can also do the past year paper lah. The past year paper is more you can access the past paper from your system. I'm not sure how, but you can. I believe you can access the past paper and try do the past paper lah on this chapter. Normally this chapter they give you only one question, combine everything, 20 marks, 40 marks in one question, because it goes step by step. In this example, I already have split that in 1, 2, 3, 4 kan. But in past year paper, if you look at past year paper, normally they give you only one question straight away, determine the last one, so you need to go step by step. That's why normally you get 40 marks or 20 marks from that question for chapter 4. Okay, right, so let's see one of the example. So the water ni kita tinggal something flows from large reservoir to a smaller one through a 5 cm diameter piping system. Okay, this is the D as shown in the figure. The volume flow rate is 6 liter per second, so this is your Q. Okay, the properties of water are density 1000 and dynamic viscosity mu 1.307 times 10 to the power of minus 3. The roughness of the pipe is 0.00026. So this is your sigma, the roughness. Determine the Reynolds number and state the flow condition of water in pipe. Alright. Anyone want to guide me how we can find the Reynolds number? Equal to how to find the Reynolds number? Apa equation dia? Reynolds number. Anyone? Dah lupa ke?
Tak ingat lah sir.
Tak ingat, tak boleh jawab lah.
Initial force bagi dengan viscous force.
Itu dia definition lah. Macam mana nak awak kira? Formula dia apa?
Average.
The
Average D bagi dengan V.
Average D bagi dengan V. Okay, tapi apa formula dia? Yang kita boleh guna lah untuk jawab soalan ni. You are right, inertial force divided by viscous force. Okay, betul. But it will not help you to solve this question. What is the equation for Reynolds number? Rho times apa?
VD
Good. Over
mu.
Over mu.
Over mu.
Okay. So you need to remember this lah. If not, you cannot answer the question lah. Okay. You don't have any formula book kan when you go to the exam? Ada ke formula book when you previously when you go to the exam hall? Did you been provided with the equation book for all the equation?
For fizik ada sikit je dekat depan.
Okay.
Depan macam tu lah.
So not all not all the question that is written in that book. Okay, so that's why you need to remember this equation, because if not you cannot answer. You cannot answer lah, kan? Okay, you need to remember this equation. Okay, so that you can answer the test or in the final exam. Okay, so the rho of this this water is 1000. Okay, 1000 times the V, the velocity. So we need to find the velocity first through what equation? Macam mana cari V? Tak bagi V je sini kan? Tak ada V. Macam mana cari V? From what equation?
Daripada Q sir.
Betul, okay. Q
equal to AV.
Oh, that's good. So V Q over A lah, kan? Okay, they provided you with the Q 6 liter per second, or you can times 0.001, 6 liter per second. And don't forget to change in meter cube per second, kan? So 1 liter is equal to 0.001 meter cube. Okay, so that means you will get 6 times 0.001, which is 6 times 10 to the minus 3 divided by area. Okay, the area from the D. Okay, they give you the diameter is 5 centimeter. Okay, so you can find your area pi times r squared or pi d squared over 4. Okay, 5 divided by 100 in meter divided by 2 to get your radius 0.025 squared. Okay, so you get your V equal to 6 times 10 minus 3 divided by pi times 0.025 squared. you will get your V equal to 3.06 meter per second. Okay, so you can you have your rho, you have your V, so put your 3.06 times the D, the diameter is 5 centimeter, which is 0.05 meter, divide by mu is 1.307 times 10 power minus 3. So you will get 1000 times 3.06 times 0.05 divided by 1.307 times 10 power minus 3. So you will get your value for Reynolds number is 11061.9. So this is more than berapa to get turbulent? What's the value? More than
4,000.
4,000. Okay, so this is more than 4,000. So this is turbulent. Okay. So this settled for part 1. And part 2, so they ask you to find the friction head loss for major head loss. Okay, and you know to get the head loss, the HL. What is the equation for HL again? Apa equation dia? Anyone? Macam mana jawab soalan ni? Ha? Apa ke?
F
F, okay. Good. F
over D
over D. Okay. F over D, okay. Lagi?
wait F L over D
L over D, okay.
L over D V square
V square over
2G
apa?
over 2G
2G. Okay, that's good. So this is the equation So apa you need to remember as well. Okay, there are a lot of equation that you need to remember. Okay, to solve the equation. Alright. So because this is the turbulent condition, your flow is in turbulent, so you need to use the Moody chart lah. Okay, Moody chart. But first to find this F to find the friction factor. Okay, to find friction factor you need to have your Reynolds number. Okay, you have your Reynolds number already, and you need to find your relative roughness number sigma over D. Okay, this Reynolds number is 1, 2, 3, 4, 5. So 1.2 times 10 power of 5. So this is your Reynolds number. Okay, and your relative roughness is sigma over D. They give you the sigma only roughness 0.0026 meter. Okay, 0.00026 meter divide by the diameter 5 centimeter, so 0.05. Okay, so you get your relative roughness 0.00026 bahagi 0.05. So it will be 5.2 times 10 to the power of minus 3, or in apa 0. Kalau you want to refer to Moody chart okay, so 0.001 0.0052 1, 2, 3. Okay, So this is your relative roughness, 0.0052. Okay, so to get your F, you need to refer to your Moody chart. Okay, kat sini kita boleh tunjuk sikit from your Moody chart. Okay, let me delete first. Apa je? Tak boleh je. Tak apa. Okay, so for this, okay, so your Reynolds number is 1.2 ni kan? 1.2 times 10 power of 5 kan? So this is, let me zoom. Okay, so this is ni 10 minus 5, 3 4, 3, 2. So 1 kat sini, 1, ni 1. So 1.2 somewhere kat sini lah, tengah-tengah kan. Oh ni saya dah lukis dah ni. So 1.2 ni nilai 1.2 saya dah buat tadi. 1.2 and your your relative roughness is 0.0052 kan. So this is your 0.0052 somewhere here. So you draw a line, and because this beyond this dotted line, so you need to do a little bit curve lah. Okay, do it a little bit curve, and that intersection will determine your friction factor. So from what I done, I get the F is equal to 0.029. Okay, if I do it properly, I do it I get it 0.029 somewhere kat sini lah, kat sini. Right, so we can go back to our calculation. Okay, to find your friction factor, so you get your F 0.029. Okay, so HL is equal to 0.029. So your friction factor. Okay, don't worry if you do it to if you do this question, might be your friend get 0.028, 0.027, okay, or 0.031. Don't worry about that differences. The important thing is how you get that value. You need to show from your Moody chart where you draw the line, where your intersection, and you draw to the left to find your F. Okay, so your answer might be different lah to one or another. Okay, maybe your friend get 0.028 or you get 0.029. So you always get difference memang akan ada chance lah to get a different answer. Okay, so don't worry about that. Okay, as long as is nearly tak jauh sangat. Kalau lah awak dapat 0.06, so that means it's totally wrong lah. It's too far, the difference is too big, so that means it's wrong. It must be around this lah, 0.029 or 0.28 to 7. Okay, so that's your F. So times L, the length. So what is the length of this pipe? Anyone? Apa length this pipe?
80 m.
This one 80 meter So that is your L, 80, and this L times V. Okay, the V you already find it, 3.06. So 3.06 squared. Okay, over the diameter 0.05, and the times 2 times G, 9.81. Okay. you can just straight away use this equation because the pipe is a constant diameter lah. It's the same pipe, okay, with 5 centimeter diameter. If you have two different pipe, that means you need to do one by one lah. Okay, we look another example after this. Okay, so if you calculate this, you will get the number is 0.029 times 80 times 3.06 squared divided by 0.05 times 2 times 9.81. So I get 22.1 meter. Okay, so that's your head loss in the pipe. Okay, the second one. Okay, the third one, the minor head loss. They ask you to find the minor head loss. So how what is the equation for minor head loss? HL minor. Macam ni cari dia. Apa equation? Anyone? Imagine.
Summation of KL.
Okay, summation of KL. Good.
Square over 2.
Apa?
B square over 2G.
V squared over 2G. Yeah, this is the equation that you need to use. Okay, so you need to sum all of the KL first in this pipe. Okay, so you have the K entrance 1, K entrance, okay, which is given here 0.5. So 1 for entrance, 1 times 0.5, okay, plus, so you have elbow, 1, 2, 2 elbow, 2 standard elbow flange with the KL is 0.3, so 2 elbow times 0.3, okay, plus you have the gate valve, the KL for gate valve fully open is 0.2, okay, 1 for the gate valve is 0.2, plus you have the exit, the exit for coefficient, loss coefficient for exit is 1.06, ada satu je exit, so 1 times 1.06. Okay, anything else? So we have entrance, we have elbow, we have the valve, we have the exit. Okay, entrance, elbow, the gate valve 0.2, exit 1.06. Okay, that's all. Okay, that's all for your summation for your KL. Okay, you add everything here. Okay, then times the V2, the velocity squared, not V2, sorry, the velocity squared, V squared over 2G. Okay, and this will give you, okay, 0.5 plus 2 times 0.3, 0.6 plus 0.2 plus 1.06. Okay, it is 2.36. So 2.36 times velocity squared 3.06 squared over 2 times 9.81. So this will give you the value for your minor head loss, which equal to divided by 2 times 9.81, 1.12. Okay, so 1.12 meter. Don't forget your unit. Okay, so this is your minor head loss number 3. Number 3. Okay, and last, finally they ask you to find the elevation Z1. Kat sini tak bagi. They ask you to find the Z1. So in this question you need, saya tambah slide sekejap. Kita cukup ruang tak? Okay. Apa dia gambar ini pula? Okay. Okay, to find the head, the Z1, the elevation. Okay, the Z1 here. So we need to use the energy equation. Right, right. So P1 over rho G plus Z1 plus V1 squared over 2G. Because we have the losses, so we need to minus the head loss, and we don't have any pump hand or turbine, so we can just ignore that. So this will equal to P2 over rho G plus Z2 plus V2 squared over 2G. Okay, so you have your HL, the total HL is 22.1 plus 1.12. Okay, HL equal to 22.1 plus 1.12. Because this is total head loss. The total head loss you need to add lah, the major and the minor. So this will be 22.1 plus 1.12 equal to 23.2 meter. 0.2 meter. Okay. Sorry. And Z2, they gave you Z2 is 4. So this is 4. Okay. 4 meter. And you want to find Z1 kan? Okay. So you have HL, you have Z2, P1 and P2. What's the value for P1 and P2? Anyone? What is the value for P1 and P2? From the equation. Berapa nilai dia?
Tak ada.
Tak ada. Tak ada. Maksudnya apa tak ada?
Tak ada open.
Maksudnya lah, okay, tak ada maksudnya zero zero lah. That's the value that I want. Tak ada, memang tak ada kat sini so because it's open, as you said, it's open to the atmosphere and the pressure ATM lah, and because it's not given, so we can assume it's zero lah. Okay, tak ada zero, so this is zero and this also zero. Okay, so you can cancel out that. How about V1 and V2 in this equation? What's the value for V1 and V2? So we want to solve this equation, so we need to know this lah. Z1 nak cari, HL kita dah ada, Z2 dah ada, ni dah cancel out. V1 and V2 ni macam mana? Macam mana lah V1 and V2? V at point 1 and V at point 2. Tu boleh cancel out tak?
Boleh kosong ke?
Kosong Dia kosong ada dua because it is come from this reservoir. Okay, and this open to atmosphere, and that's why you can, this is zero. Okay, you can cancel out also lah, V1 V2. So that means with left with you is only Z1, the one that you want to find, equal to Z2 plus HL again. HL. So Z2 is 4 plus HL. Your HL is 23.2. So 23.2. So you can get your answer for Z1 is 27.2 meter. Okay, so that's how to solve everything lah, and in this equation, this question. Okay, so this is quite simple because you don't have any pump or turbine, but still the step is quite long, so that's why you will get 14 marks or 20 marks lah. Sometimes give you 40, or if there's more than that you can get 20 marks. Okay, any question about that example?
Sir,
Yeah.
sepatutnya yang dia punya pressure tu kan dia patutnya ATM kan. Kalau dia tak bagi, kita kena assume dia sebagai zero
Betul.
Okay sir, thank you sir.
Alright. Okay. Anything else? Any more question? Tak ada? Okay, we go to the second example. Okay, so this lain sikit lah, but still don't have any pump. Dan dia pun tak ada pump juga. Okay, never mind. Okay, so this example, water 1000 with mu flows through a piping system shown in figure. Example, the pipes are made of wrought iron. Okay, this is the material of the pipe. The length 1 and diameter of each are given as follows. So you have two different pipe lah. So pipe 1, the black one, and pipe 2, the black one juga tapi kecil sikit. Okay, so the pipe 1, the length is 60 meter, diameter 0.289. So this is bigger lah than this smaller pipe. The smaller pipe has 22 length in meter and 0.194 in diameter in meter. Okay, the volume for it is given 0.05. So this is Q. Again, determine the Reynolds number. So who can help me to find the Reynolds number in each pipe? Ada dua lah. So one for pipe 1, another one is for pipe 2. So again, what's the equation for Reynolds number? By this time you need to remember dah kena hafal lah the Reynolds number equation.
Rho VD over mu.
Over mu. Okay, it's quite simple je sebenarnya. Okay, the value rho is 1000 times V. Again, you need to find the V lah from the Q. Okay, V equal to, for V for pipe 1, 0.05 divided by area pi r squared. Okay, R is 0.289 bahagi 2, 0.289 bahagi 2, 0.1445 squared. Okay, what's the value for velocity? Can someone help me? The velocity for pipe 1, V1.
0.76.
0.76. Okay, and the D for this pipe is 0.289. Okay, 0.289 divided by mu. So mu is 1, 1.01, 1 times 10 minus 3. Okay, what's the value for Reynolds number for pipe 1?
219640.
219640. Okay, so this is more than 4000. So this is turbulent turbulent. So the next one, the Reynolds number for pipe 2. Again, the rho VD times over mu. So rho 1000 times V. So you need to find the V2 lah. V2 is berapa? V2 dah kira? V2 0.05 divided by pi r squared, 0.94 divided by 2. Berapa velocity for pipe 2? Berapa? Ada yang kira tak? 0.05 divided by pi times 0.94 bagi 2 square. Berapa? Tak ada orang kira kan?
Dapat 1.69.
1.96
1.69.
69.
Okay. V times D diameter 0.194 divide by mu 1 times 10 minus 3. Okay, so that's number for part 2 is berapa for part 2?
327
327
860.
860. Again, it is turbulent lah. Okay. Okay, so that's settled for one. The friction head loss. They ask you to find head loss in each part. Because the pipe is different and you have different diameter, so you need to find one by one lah. Okay. For the first pipe, okay, the head loss. Again, the head loss, the major, friction ni major lah. Major head loss. Apa value dia? Apa equation dia? F
L over D
times
V square over
G
2G.
squared over 2G. Okay. So you for pipe 1, so you already have your Reynolds number is 2.2 times 10 power of 5. You need to find your relative roughness. Okay. Number is bagi tak? Sini tak bagi They gave you the material for this part is wrought iron. Okay, you can find from your Moody chart. Okay, from your Moody chart. Okay, find your material. Wrought iron is this one. Okay, wrought iron is 0.0 berapa ni 0.04 what? Tak nampak. Let me refer to my 0.046. Okay, so your your relative roughness will be 0.046. Okay, this in millimeter so you need to divide by 1000. Okay, and divide by your diameter diameter. The diameter of pipe 1 is berapa tadi? Pipe 1 0.289 pipe 1 0.289. Okay, so go back to your Moody chart. 0.0289. Okay, berapa nilai ni? Kalau kira 0.046 divide by 1000 in meter divide by diameter of the pipe 0.0289. Berapa nilai relative roughness?
1.59
1.59. Okay.
times 10 power of negative 3.
Negative 3. Or we can write it as 0.0015 16 lah 1, 2, 3 Okay, so you have your relative roughness and you have your Reynolds number 2.2 tadi kan, 2.2 times 10 power of 5 kan. Okay, so you can refer to this Moody chart. Reynolds number 2.2. This is 2. So your 2.2 kat tengah-tengah ni lah 2.2 buat di atas straight line, and your 0.0016 is 0.0016 0.002 so your 0.016 in between lah betul. So this is your 0.0016, so you need to draw a line, okay, and after this dotted line you need to draw a curve draw the curve line, okay, curve line, and mana 2.2 mana 2.2 ni 2.2, okay. So this intersection is your friction factor, go to the left, this intersection, go to the left, okay, you will get your friction factor lah somewhere about 0.02 berapa nilai awak nak bagi nilai ni 0.023 okay, 0.023 okay, go back to your calculation, this one, okay, so your F is 0.023, okay, so you can plug in your value in the equation 0.023 times L, the length of this pipe lah for pipe 1 60 meter, okay, times the V for pipe 1 is 0.76 0.76 squared over D, diameter of pipe 1 0.289 0.289 lah, salah kita buat kita buat dia 0.00 ke betul? Oh ni salah ni, alamak ni 0.289 kan, salah kan?
Yes sir, patutnya 0.289.
So this value salah lah.
Value tu betul sir.
Dapat 1.59 darab 10 negatif 4.
Oh, negatif 4. So
salah tu je kuasa.
So 0.000 lah. Ada 3 0 kan?
Yes.
So 3 0 kat mana? 3 0 dekat 000 kat sini lah maksudnya. Kan?
Yes sir.
So draw a line after this dotted line. So you need to draw a curve until you get the intersection with your 2.2 10 of power 5 kat sini So sini bawa ke tepi. So you get maybe berapa 0.017 boleh roughly lah 0.017 okay, 0.017. So you can plug in your value in your calculation 0.0017 okay. So divide by D 0.289 times 2 times G, berapa nilai dia? (0.017 times 60 times 0.76 squared over 0.289 times 2 times 9.81. Berapa head loss, the friction head loss for pipe 1? Dah kira berapa?
Dapat 0.104.
0.104. Okay, 0.104 meter Don't forget your unit. So this is for pipe 1, and you do the same lah for pipe 2 For pipe 2, the same thing. Your Reynolds number 3.3 3.3 10 times 10 to the power 5. You need to find your relative roughness. Okay, relative roughness divide by D. Okay, the wrought iron, so divide by D, 0.194. Okay, so you will get your relative roughness number. Mana tadi? Ni kan. So wrought iron 0.046 divide by 1000. This is in millimeter. Don't forget. Okay, and divide by the D for pipe 2, so you get your relative roughness. So you do the same lah. Okay, I think I don't need to show you that lah. You can do that by your own. Okay, dah 11.5 dah. Okay, so you get your you can get your version head for pipe 2. So and then the minor head loss in each pipe. Okay, again the formula is apa formula for HL minor? Summation of
K
KL times
KL times V square over 2G.
over 2G kan. Betul kan? Times KL kan? Summation of KL kan? The loss coefficient of the minor loss coefficient. So for pipe 1, so you have valve, satu valve. Okay, use this one 0.15 kot typo 0.15. Okay, you have one loss coefficient, and you have elbow, one elbow and two elbow, three elbow, four elbow. So 4 elbow for pipe 1. Okay, 1, 2, 3, 4 . Okay, so summation of KL for pipe 1 is 0.15 plus 4 elbow, 4 times 0.31. Okay, so you find this, then times the velocity squared times over 2G. So you will get your minor head loss for pipe 1. For pipe 2, okay, for pipe 2 you have one for the sudden contraction. Ni kan, daripada besar ke kecil, so this is a contraction. Okay, so you will so this information will lost in pipe 2 lah. Okay, so 0.35. So 1 times 0.35 plus you have 45 degree elbow kan. Ni kan, 45 degree elbow 1, 2 and 2 45 degree elbow. So 2 times 0.17. Okay, so you add this, you sum this two loss coefficient times the velocity for pipe 2 over 2G, you will get your minor head loss for pipe 2. Okay, ada nak tanya? Tak faham? Jelas kan? Ada apa-apa? For this one, I'm not sure you the ni lah, malas dah apa. You can do it by own lah. Summation times V squared over 2G. Summation times V squared over 2G for each pipe. Okay, boleh faham
Boleh sir.
Okay,
Boleh sir.
settle this. The last one, they ask you to find the pressure drop P1 minus P2. P1, so dia ada gauge kat sini and gauge kat sini P2. So they ask you to find the P1 minus P2. Again, you need to use the energy equation to apply that. P1 over rho G plus Z1 plus V1 squared over 2G. Okay, minus the head loss that you have calculated here, the head loss, and we don't have any pump, so that's, we don't have any turbine, so let's ignore that. This equal to P2 over rho G plus Z2 plus V2 squared over 2G. Okay, so they ask you to find P1 minus P2. So you need to bring this term to the other side. Okay, so you can write your equation in terms of P1 minus P2 lah. Okay, so you have Z1, so Z1 is 3 meter. Ni Z1. Okay, this is Z1, and you have Z2, so this is Z2. Okay, 2.7 2.7. Okay, you have Z1 and you have Z2 and you have HL, you need to calculate lah, from minor loss plus major loss. So this will get your head losses, total head loss. And you have V1 for this pipe from mana dia kira 0.76, and you have V2 lah for this pipe kan. So V2 berapa tadi kira 1.69 ni kan, ni V2 kan. V2 and V1. Okay, so you have V1 and you have V2. Okay, so you can solve lah for this pressure drop. V1 minus V2 kan. Okay, just calculate lah berapa nilai dia. Okay, ni semua dah ada kan, so just calculate lah. Okay, ni boleh faham?
Boleh sir.
Boleh
Sir, nak tanya.
betul.
HL dia part 1 ke atau part 2 sekali?
Sekali lah, total semua sekali.
Ya.
So you need to add the major loss for part 1 plus the major loss for part 2 plus the minor loss for part 1 plus the minor loss for part 2. Semua sekali. So ni the total head loss kan. Kita dah cover kat sini mana saya balik. Ni kan total head loss ni. So you need to add the HL major plus HL minor. If you have two different pipes, so you need to add that two different pipes. Boleh? Okay. So that's why dalam question ni dia bagi macam ni FI, LI, VI depends on your, if you have two different pipes, so FI for apa? For one pipe and second pipe. If you have only one pipe with constant diameter, so you just can use this equation lah. Okay. Right. Anything else? Any more question regarding that? Okay. Tak ada? Anda tanya ke?
No sir.
Tak ada.
Tak ada sir.
Okay. So example 4 pun, I think you can do it by your own. Maybe I just show a little bit lah. So you have two reservoir and flow from here, from ni flow dia kan, ke dari atas ke bawah dia akan flow dari sini lah nanti to the reservoir Okay, so they give you everything. So they want to find the vertical distance between the surface from point A to point B. So they ask you to find this vertical distance. Okay, Z. So they give you the mu. Okay, and they give you the Q. Okay, they give you the total length. So there are two different pipe juga. Satu yang diameter 100. Okay, this one. Yang ni sampai sini. Second one, pipe ni sampai sini. Okay, so two different pipe with two different length and two different diameter. So from here you can find your both lah major loss and minor loss Okay, HL major and HL minor. Okay, and they give you the relative roughness. Okay, they give you already for both pipe. The relative roughness for both of this pipe is 1.2 times 10 power of minus 4 Okay, minus 4 Okay, so they give you the relative roughness. So you can find your Reynolds number and for both pipe, and then you can find your friction factor to get your major loss. Okay, and you can find your minor losses from this ni lah, from this loss coefficient. For minor ada elbow 1, 2, 3, 4. Ada entrance, so this entrance and this is exit. Okay, and you have the enlargement. Okay, this one kat sini enlargement from kecil to besar Okay, so this is for this part lah, for part 2. Okay, and gate valve, so you have gate valve kat sini, and this only for part 1 part start the valve. Okay, so you can calculate your total minor losses for both part. Okay, and find add the major losses and minor losses, that will give you the total head losses and in your energy equation. Okay, and they ask you to find the vertical distance. Again, you use the energy equation, rho P1 tambah over rho G plus Z1 plus V1 squared over 2G plus the head losses, the total head losses, and you don't have any pump and turbine, so that's only then sama dengan equal to P2 over rho G plus Z2 plus V2 squared over 2G. Okay, so they ask you to find Z1 minus Z2 lah. Okay, or you can assume the Z2 ni 0 boleh juga Let's say you take this is your reference line, the datum line. Okay, so this is 0, so Z2 is 0 lah. Okay, they ask you to find the vertical distance kan. So you want to find Z1. Okay, the question is what is the P1 and P2? Again, can we cancel out this? P1 and P2. Apa nilai P1 dan P2? Anyone? Hello? Berapa nilai P1 dan P2? Zero lah Okay, because this is open to atmosphere juga even though it looks like dalam reservoir this point is open to atmosphere lah okay, and you can just assume that you can just guess from the question. It doesn't give you anything it doesn't give you any value for pressure at point A and point B. That means the pressure is 0 lah. Okay, so you can cancel out P1 and P2. Okay, so you dah habis. So V1 you can find your V1. No, you cannot find your V1 juga. V1 apa? V1 dan V2 kat sini V point A and V point B pun kosong lah because this is large area so the velocity at this point is very very small. Okay, very negligible. We have discussed this in chapter 3 kan. If you have a very large surface area, so the velocity at that point, okay, compared to the velocity in this pipe, this one is very very small. Okay, so you can cancel out this V1 and V2 juga. Okay, boleh? Faham? Boleh kan?
Boleh sir.
So you can just find your Z1 lah through this HL lah. You find your HL ni dah actually is sama dengan your Z1 lah, your vertical distance here. Okay? Boleh? Tak ada soalan lagi? So Z1 ni sama dengan loss je lah. Okay. So that's all I think. You can try do the other tutorial question in the Google Classroom. I post the two set of question for this chapter. Okay, you can do that. I suggest you to do that. Okay, so that you understand how you can use chapter 4 or the equation in chapter 4. You will not remember it until you do the question lah. Lot of equation for Reynolds number, for the friction losses, the major losses and the minor losses, and also the long energy equation. Okay, you will not get used to it until you do the question. Okay, so that's why I suggest you to do that. Okay, if there is no answer in that question, you can just ask me lah. You can just show me your step by step, and if I think the step is fine, then the answer is correct lah. Okay, and your answer highly likely very different to your friend's answer, because your F will be different, because you draw the line from your body chart, you will get a different value for F. Okay, very high percentage to get a very different value for F. So that's fine. No, don't worry. If you compare your answer with your friend, you get different answer. But make sure the difference is not too big lah. If lebih kurang tu, that means is betul lah, correct. Okay. Alright. So that's all for today, I think. Thank you for your attendance.